are going to go on to 7.7. It is very similar to what we were just working on. 7.7, we're going to talk about exponential growth and decay. Remember that the equation we use is y equals ab to the x, where a was your y-intercept, which is also what we consider our starting place, right, or our starting, is our a value. Our b is our growth or decay. If b is greater than 1, then it's a growth. If b is between 0 and 1, it's a decay. That's what we talked about yesterday, right? So in the very first section in your homework today, you just got to state what A and B are. So example number 1. This is for problems 9 through 12. State the initial value and the growth factor. All right, so y equals 3 times 2 to the x. All you have to do is say a equals 3 and b equals 2. Try another one. Y equals 1.5 times 7 to the x. What is my a value? Good. What is my b value? Perfect. What if I had y equals 1.05 to the x? What is my a value? 1. Good. A equals 1. There's that magical 1 in front. What is my b value? Good. 1.05. That's the first 4 problems. Super easy, right? Okay. Now I need to talk about a couple equations we're going to use that are similar to y equals ab to the x. But we're going to start to apply things. All right? So, for y equals ab to the x, if, whoops, that's to the x, sorry guys. If it is an increase by percent, so it's a percent growth, then our equation is going to change just a little bit. It is going to be y equals our starting amount, which I'm going to use p for, times 1 plus r to the t. Okay. So P is in the same place as A. So P is our starting amount. R is going to be the rate as a decimal. So if it's 5%, it's 0.05. And T is the amount of time. If it's not a percent, but a multiplier growth, like double, triple, that's a multiplier growth, then it would be y equals p times, we're going to use our b value to the t. That's not b, that's a d. I do not know what I'm doing today. All right. Okay, so where P is your starting amount, B is your growth factor, whether it be double, triple, whatever, and t is the amount of time. Okay, so example number 2. For example number 2, this is what you are using for 13 and 14. Let's say I bought 20 rabbits for Easter. They increase by 50% every, we'll say 6 months. How many will I have in 5 years? All right, so we have y equals, how many am I starting with? 20. And it's increasing, so I say 1 plus. How do I write 50% as a decimal? 0.5, very good. The last trick is our exponent. It's the amount of time. What happens every 6 months for 5 years? How many times does it happen? 10 times, right? Every 6 months for 5 years means it's going to happen 10 times, right? Twice a year? All right, so now we're going to grab our calculator and we're going to type this in. Find out how many wonderful rabbits I will have in 5 years. How many did you get? 1154. Yep, very good. 1,154 wonderful bunnies. Yeah, you got to round up because you can't have part of a bunny. You got to count the whole thing. Okay. That's right, or he wouldn't be considered a bunny, would he? All right. So, again, we always set it up as 1 plus the percent as a decimal. Do we have a question? I have some head shaking. I see some people. Give me questions. We don't have any questions? Okay. Well, let me do another one then to make sure we're understanding. Example number 3. Example number 3. Let's say we have a population of 7,500 people, increasing at, how about 5.5%, each year for 10 years. How many people will we have? To start with y equals, our starting amount is 7,500. 1 plus, how do I write 5.5% as a decimal? Good. 0.055. And my exponent is 10. Right? It happens each year for 10 years. So we grab our calculator again. We type in 7,500. 1 plus 0.055. Raise it to the 10th power. We get 12,812 because we can't have part of a person. Again, questions? Okay? Next section, we've got to change this equation just a little bit more for what we need next. We're going to talk about compound interest. So my equation is y equals p, parenthesis, 1 plus r over n to the nt. So I've added another variable. P, again, represents the starting amount. R is your rate as a decimal. N is the number of times it occurs each year. And T is the number of years. So let's talk about N for a minute. When we talk about N, if I say annually, how many times does it happen per year? 1. If I say monthly, how many times does that happen per year? Okay. If I say weekly, how many times does that happen per year? 52. Very good. If I say daily, 300 and there we go. What if I said quarterly? Good, that would be 4. So those different numbers are going to come into play in our N in this next section. All right? So I'm on example 5, right? 4? 5? 4. Holy cow, I haven't gotten hardly anything done yet. Example 4. This is the next section, which is 15 through 22. All right, I'm going to tell you that I deposit, let's say, $5,000. Yep. $5,000 compounded annually at 6% for 7 years. So we start with y equals, our starting amount we deposit is 5,000, parenthesis 1 plus. My rate as a decimal is 0.06. What is my n? Compounded annually. 1. Very good. My exponent then is 1 times t, which is 7. Now we grab our calculator and type this in. So we get 7,518.1512. But this is money. Is that a money number? Okay, so what we do with money is we do what we call truncate. We cut off everything past the hundredths, past our pennies. All right, so that would be our answer right here, 7,518.15. Let's try another one. Example number 5. Let's say I deposit. Let's go with $2,500. Compounded monthly at 6% for 15 years. How much will I have? So we have y equals, our starting amount is how much? 2,500. We have 1 plus our R. 6% is 0.06. Compounded monthly means N is going to be what? 12. Very good. And then in my exponent, I have 12 times 15. Go ahead and type this into your calculator. So check and make sure you type it in correctly. You should get, Ashton, you should get $6,135.23. So try typing it in again if you didn't get that. So questions on this part? And no stresses. We're going to do another worksheet on this tomorrow. It's not a big deal. We're just starting, okay? Example number 6. Example 6 is similar to the very first example we did. This is 23 through 26. State the initial amount and the decay factor. So if I have y equals 3 times 0.75 to the x, what is my a value? 3. What is my decay factor? 0.75. Say I have y equals 7 times 0.11 to the x. What is my a value? What is my b value? 0.11, exactly. That's all you have to do for those 4. All right. Okay, 27 real quick and then I'm done. All right. Example number 7. This has to do with number 27. Let's say I have a population of 7,000 and it decreases by 6% each year for 10 years. So because it decreases, the only difference in our equation will have y equals 7,000, and instead of 1 plus, it's going to be 1 minus our rate as a decimal to the 10. That is the only difference when it says decreases. It becomes 1 minus. All right, and then you can throw that in your calculator. Do we have any questions? I apologize for not giving you time in class to get anything done. I think the calculator portion, which I thought would only take a couple minutes, kind of took a little bit longer, so I apologize.